Hello students, class 8 once again. I am Sunil. Welcome back to my video. In today's video, I would like to show the solutions of exercise 11.3 here. So exercise 11.3 will mostly deal to find out the surface area or total surface area. Means lateral surface area or total surface area. What is the total surface area of solid shape, cube or cuboid? Okay, or a cylinder, or lateral area surface of the cube void. I have been shown in my previous video, so today we will start the exercise 11.3. So 11.3, question number 1 is so simple, you have to apply the formulas only. So question number 1, I'm just leaving and I will start from question number 2 here. So in question number 2, it is saying that a suitcase with the measures of dimension 80 centimeter, 48 centimeter and 24 centimeter is to be covered with a tarpaulin cloth. How many meters of tarpaulin of 96 centimeter is required to cover such 100 suitcase? So what we are going to do is that we are going to find out the total surface area. See, we have to cover the whole surface, isn't it? So what is the shape of the suitcase? Suitcase is having this having the shape of cuboid, isn't it? So we are going to find out the total surface area of the suitcase. That means we are going to find out the total surface area of a cuboid, isn't it? After that, we will multiply with the number of cloths that's required for one suitcase. So let us see how we can do it. So my first time we have the dimension of the suitcase, that is 80 centimeter into 48 centimeter into 24 centimeter. So what is this dimension? They are the length, breadth and height. Length, breadth and height of the suitcase. Okay. So we know that the total surface area of cuboid. Cuboid. Why am I making cuboid or suitcase? Because suitcase is the shape of cuboid, isn't it? Is equal to 2 into LB into LH into BX. Isn't it? L length, breadth, L length, H height, B breadth into height. Okay, so that means 2 into LB how much? 80 into 48 plus, this is not into, okay, sorry, plus here plus LH is length 80 into 24 plus B length 48 into height 24. So we multiply this and add them, okay, and multiply with 2 again. So in the bracket, what is the answer? Let us see. Yeah. So therefore then here I got for this 3,480 here, 1,152 here, 1,920. Yeah. So this is to be multiplied. We have to add this all first and multiply with 2. Then we get the square here for this area, isn't it? So the total surface area of cuboid. So the total surface area of the cuboid now will get here 2 into this, if you plus this, then you are getting here 6,912 centimeter square. So how much is that? If you multiply total, then is 13,824 centimeter square meter. Okay, clear? So this is the total surface area of the suitcase, of the one suitcase. And the question is asking about 100 suitcases. Okay. Given that a tarpaulin means this is a material to make the cover of one suitcase. So tarpaulin is there having weight of 96 centimeter. So asking how much such tarpaulin may be required to cover 100 such suitcases. So we are going to find out the area of the 100, total surface area of the 100, total surface area of the 600 suitcase. Okay. Now let us see. Next part what we have. Another area of the tropoid. Area of 1 meter of this one. Tropoid. Okay. Troponin 1 meter is 100 centimeter, isn't it? Into 96 centimeter. Then into breadth. With this one. Why? Because 1 meter there will be 1 meter length, 1 meter long. Okay, why is given here as 96 centimeter, isn't it? 96 centimeter is given here in the book, so the area of this troponin, we said the wide of 96 centimeter, which is 1 meter, then this much of area. Okay, then we are getting here the area how much? 960. Yeah, 900. 9,000, 9,600 centimeters square we are getting. Yeah. So this is the area of 1 meter of a tropoid, and this is the total surface area, okay, of one square. So we are going to find out the tropoid required for 100 such suitcase. Therefore, the tropoid required equal to 100 into one suitcase area of that means total surface area of one suitcase. That is 13824 centimeter square divided by here your this one 9,600 centimeter square. And in this first multiplication we will get down figure here. So these two multiplication image and we are going to divide this 1,824 by 96. And then how much we are getting here? Let us see. We get here this yeah. This multiplication is 1 4 this much of meter is required for the tropoid having what as 96 centimeter. Okay, so this is the answer for question number 2. Then we are going to the next question, question number 5. Okay, so question number 5. Next question. So my next question is question number 5. The question number 5 is saying that Daniel, one boy is there. He used to paint the 4 walls and the ceiling, okay, of his room. So actually in painting 4 is not going to paint, you see, but the total surface area, the room is shape of cuboid. So total surface area of the cuboid we know that, isn't it? So what happens from this total surface area of the cuboid, ceiling is there, but floor is not there. So what happens? One area of surface will be surface of rectangle, isn't it? Even the surface of rectangle. So if we subtract area of one surface from the total surface area of the room, means cuboid. Okay, if we subtract one surface area of the total surface area, then we get the total surface area to be painted. And again, we have to find out how many can of paint is required. One can be painted up to 100 meters square. So then we have to find out how many cans are there. First of all, how much the paintable area, how much to be painted, how much how much surface area is to be painted. So first of all, this is the dimension of the wall given here. The dimension of the wall of the room, the dimension of the room is given here. Okay, dimension of the room. Dimension of the room is that the volume of the room. The volume. Okay, the volume. This is the volume. the dimension, then integrate into height. Dimension of the cuboid. Room is 7G. Room is the example of the cuboid, isn't it? So that dimension is given here, length into height. Length, height. That dimension. Okay, 3D set only your room is or the room is. So what happens? We find that total surface area of the room, of the dimension of the room. Then we subtract one surface area, so that we get the exact area to be painted. Not all, because floor will not paint. Floor will be subtracted. The area of the floor. Floor will be the same of a rectangle L into B. One L into B. You find that 2L actually surface area. Okay, not surface area. Total surface area. Total surface area. Total surface area. Surface area of the room will be 2 into L into B plus L into height plus B into height, isn't it? Yes. So this LB, 1 will not be there, right? Because another one, 2 LB will be there, isn't it? One will be for the ceiling and another will be for the floor. So floor 1 will not be included here in painting. That you have to remember. Therefore, minus LB. 1 LB. So you will get here 2 into here, that means L 15 into 10 plus 15 into 7 plus 10 into 7 meter square minus LB will be 15 into 10 meter square. Yes. How much we are getting? Let us see. 2 into in the bracket. We get here 150 plus 105 plus 70. Okay, meter square minus this will be 150 meter square. Now you get here 2 into 300 and 300 and let us see plus all this 0045. 5. Then 7, 12, 2. 325 meters square minus 150 meters. Then how much will get here? You see, this will be 650. Yes, 650 meter square minus 150 meters square. That means you are getting here 500 meters square. So 500 meters square is the total surface area to be painted. Now what happens? Number of can. One can print. One pen can print the area of 100 meters square. 100 meters square, isn't it? Therefore, since one can of pen can get 100 meters square. It is given in the book. I am rewriting again. Okay. Therefore, number of can required will be total surface area by the area to pen by 1 can. Total surface area is 500 meters square divided by 100 meters. That means 5 cans. 5 cans are required. Okay, so this is the answer of the question number 5. Very simple. Okay, so that is some other question also you can try, and if you have any doubts, you can ask me. If you have any problem, then you can consult with me. So let us go to the next question. So please note down, my dear student. Now we have total area to be painted and 1 can and 100 meters square. So number of can required will be total area by the area to be painted by 1 can. 100. If 5 cans, there are 5 cans. So let's go to the next question. Hello, my dear friend. Next question we have question number 8. In question number 8 is very simple. I will read out the question. The question says like this: the lateral surface area of a hollow cylinder. Hollow cylinder is lateral surface area, not lateral surface area of hollow cylinder. Area of this part, okay, the body part, not top or bottom. So it is the area is 4,224 centimeters square, and the and the question saying that this cylinder, if we cut along the cut along the height and straight, then we will get a rectangular shape. That we can find out. Any can, any bottle we cut along the not bottle, can. Okay, any can we have some can, isn't it? So if we cut along the line of height, then we stress, then you will get the shape of rectangle. So that rectangle is saying that the breadth of the rectangle will be 32 centimeters. That means the height will be 32 centimeters. The height should be 32 centimeters. Then you know. So this height is the breadth. So that breadth is 32 centimeters. So asking you to find out the length of the rectangle. So length of the rectangle will be this circumference. So don't confuse with the circumference, but you will see that circumference will be straight, it will become a line, and it will become the length. So we are going to find out the length. But what happened? Area is given here. So area of the rectangle is length to breadth. So from this area we can find out the length, isn't it? After that the question is asking us to find the perimeter of the rectangle. Perimeter, you know that, isn't it? So we find out. Okay. So what is that? We are going to find out length of the rectangle, also perimeter. Perimeter of the rectangle. Very simple. So we know that, what we know? We know that area of the rectangle. Area of the rectangle is equal to area of the lateral surface. Lateral surface of the cylinder. So lateral surface area is given here how much? 4224 centimeters square. Now area of the rectangle implies that how much is length into breadth. So breadth already given here as 32 centimeters, isn't it? Yes. So no need to write again the breadth here. We got the length into this 32 centimeters. Okay, then L, length. How much length will be? Length is equal to 4224 divided by 33. So this will divide by 33, then we will get here centimeter, then we will get here 128 centimeter. So the length is 120 centimeter. After we know the length of the rectangle, then we can find out the perimeter. That is 2s into L plus B. Okay. So therefore, the perimeter is equal to twice L plus B, that is 2 into L over now 128 plus 33. How much is that to see? 2 into 11, yeah, that means 161 centimeter. That is equal to 3, 2, 2 centimeter. So this is the perimeter. The answer is 120 centimeter as the length and 322 centimeter as the perimeter of the rectangle. So with this, let's go to the next question. So please note down this as the solution for question number 8. Now let's go to question number 9. Question number 9 is very interesting one and also little logical. Okay, so we have to put your logic here. Don't worry. Everyone is to use the idea of the total surface area and lateral surface area only. From there, some division, some multiplication, some subtraction, addition have to be done. Okay, applying the logic of equation. Now, next is question number 9. The question number 9 saying that a rod order. Okay, a rod order. You know what's rod order? Rod order is that used to make the or to make the rod. Okay, you can see the picture here. You can see the picture here. So, a rod order takes 750 complete revolutions to make one over a level to revel a rod. Okay. Find the area of the rod if the diameter of the rod is 48 centimeter and the length is 1 meter. See, you know that roller also like this. For example, this is roller. Okay, roller. We use this roller for leveling the rod, leveling the rod, isn't it? So roller also having some kind of cylindrical, what to say, wheel. Very big cylindrical wheel, and it's roller only. So this roller can complete 750, okay, 750 revolution. Rolling means revolve, isn't it? Yes, revolve. Revolve, okay, and complete 750 revolution to level a rod. So it's saying that find the area of the rod if the diameter of this rod, diameter of this rod is how much? The diameter of this roller how much? It is 84 centimeter, and length is 1 meter. I guess 10 centimeter. This thing you have to written here. Okay. So now we are going to find out, first of all, the area, the lateral surface area of the cylinder. Lateral surface area of the cylinder. This is cylindrical roller, isn't it? So total lateral surface area. With that only it will be rotating complete to level the ground or road, isn't it? So how much it over to level? Okay, by completing 750 revolts. How much area is completed by this revolts? So we'll find out the area of this lateral surface and multiply with 750. Finish, then you are getting the total area of the rod. That's all. Okay, because here and there again roll and it complete the revolution, isn't it? With this revolution it complete with this rotating. We say revolution or rotating. We say rotating. So घुमा रहा है revolution. एक घुमा रहा है. कितना घुमाता है? 750 times घुमाता है. It is revolving 750 times to complete revealing the rod. So how much the area? So area of this cylinder. The area of this lateral. If you multiply with this, then you will get the total area of the rod that level by this roller. Okay, very simple. So we'll find out the lateral surface area of the cylinder. But what we have to do is here, see, here we are going to start like this. Number of revolution made by the cylindrical roller is equal to 750. Okay, now diameter of the cylinder, diameter of cylinder is equal to 84 centimeter. That means radius. We need this radius. Radius of the cylinder is equal to how much? 84 divided by 2. That means 42 centimeter. Now, length will be the height of the cylinder is equal to 1 meter, that is equal to 100 centimeter now. Isn't it? 100 centimeter. Then we can go on. So 1 meter have to complete into the convert into the centimeter, then is 100 centimeter. Okay. From there, what we are going to find out? We are going to find out the lateral surface area. Lateral surface area of the cylindrical roller. Lateral surface area of the cylinder or lateral surface area of the roller. You know, roller is the cylindrical piece, isn't it? So how much that the lateral surface area? Yes. So it will be, yes, this. So lateral surface area of the roller or cylinder is the curved surface. That is the surface. Curved surface, isn't it? Curved surface. Curved surface. So there is 2 pi RH. 2 pi RH. Okay. 2 pi RH is the formula. So we apply here to 2 pi 22 by 7 r. How much are we getting here? 100 centimeter into then how much is there? 42 centimeter. 7 and 42 can be cancelled. Yes. How much? 7 6 are 42. Isn't it? 7 6 are 42. Then we multiply all these things. Now here 6 into 22 plus okay. 6 into 22 how much? 22 into 6. So my dear student, now we have a guess here. The lateral surface area of the roller is 2 pi RH. So 2 here pi we know is 2 by 7 r because 100 centimeter and h we can here 42 centimeter. Now here you see if we multiply all these things we are getting here 300 and 264 centimeter square. 264 centimeter square. So what happens if we want to convert into meter? Then we are going to convert this into meter by dividing by 100. That is equal to 2.64 meters. Okay, 2 point this meters. That's what we do. We got here, so another 100 is here, isn't it? Another 100 is here. That means 26400. Isn't it? So there, what happened, my dear student? This is centimeter square. So if you want to convert it to the meter square, then what we are going to do is that we are right here equal to 26400. Okay. Meter square is going to be converted to this is centimeter square. We want to convert into meter square, then it's equal to 26400 divided by 100 into 100 meter square. Okay, 100 into 100 meter square. 100 meter, 100 meter, 100 meter square. Understand? That means we got here 2.64 meter square. So this is how much the lateral area of the surface means lateral surface area. This is how much the area of the lateral surface here of the cylinder. Now this is the area of the curved surface of the cylindrical roller. Now how many revolutions it takes or it completed? 750. 2 level isn't it? Revolution rolling, isn't it? Again, 750 times. So multiply this. Therefore, the area of the level rod equal to 750 into 2.64 meter square. Find out this answer. So if you multiply this, then we will get here 1980 meters square. 1980 meters square. So this is the total area of the growth leveled by this roller with 7 diameter of 84 centimeter and the wide of 1. That's all. Okay, clear? So here, so let us do this. Just note down this. If you have any difficulties to understand, please kindly ask. So my dear student, now next question is question number 10, the last question of this exercise 11.3. This question is very interesting question and I don't want to do this for you, but I want to make you to try yourself. Okay, very simple and very little logic here, but I'll give the hints here. The figure is given like this. There is a can of milk. Okay, so a company used to put a label. You know that cans are giving some label here, isn't it? So what happened? They give the label here in the lateral surface, lateral part of the body of the can. Okay, so they used to cover the label, cover with the label. Okay, in such a way that from top it will be 2 centimeter, from bottom also it will be 2 centimeter of the can, and they start making the level. They start putting the level, okay, around the lateral part of the can. Lateral part is cylindrical. Can is a cylinder, okay, and it says that the total height of the cylinder, the total height of the can is 20 centimeter, and the diameter is 14 centimeter. So you need to find out the total area of the level. So now what we have to do is we have to find out the area of this level. Okay. See, lateral surface area, lateral surface area. How much is that? This twice h into L plus B. Wait, this is for cuboid. For cylinder, it is twice pi r h, isn't it? Yes. So this is the formula to find it. 2 and the pi is okay. R. Radius defined from the diameter. Height is 2 centimeter. But what about this height? This height is only that you have to do, because height of the level. Height of the leveling, leveling, height of the leveling part or leveling portion of the can will be 20 centimeter minus 4 centimeter. This part you should not forget this, because from here to here only level. This 2 centimeter from bottom from up will be no penalty, isn't it? No level. So leveling part only area I need to find, isn't it? Area of the leveling part only, so you should not forget this height. How to get the height of the leveling area. That's all. So with this little hints, this question number 10 is very interesting one and also simple. Okay. So with this, we come to the end of this chapter 11.3, and the rest of the questions, please reply. And if you have any questions, please ask me. Okay. So let us go to the next part of this chapter. Hello, my dear student. Next, we have the next part of the chapter. That is last part of the chapter: volume and the capacity. So, what is the volume? We are talking about the volume in everyday life, and what is this volume in mathematics? So, this volume is very important to know in mathematics. So, what is the volume? So, volume, you know that you have studied in science also. What is the volume? Volume of matter. What is the volume of the matter? Volume of the matter is space occupied by the object is called volume, isn't it? Yes. So volume. Volume is, you know that volume, what is the volume? Volume of any substance. Volume is the space occupied occupied by the object. The volume space occupied by the object is called volume. Okay. So for example, yes, you see here, my dear student, this is a water bottle here. We have it. So water bottle. So volume means the whole body is occupying a space here, isn't it? So this is a space. You know, the thing is here in this air is a space, isn't it? So now if I keep this bottle occupying some space here. So the amount of space occupied by this object is called volume of the bottle. Volume of the bottle is the amount or the space occupied by the not amount. Space occupied by the object is called its volume. And what about the capacity? Capacity, you see how much that volume is occupied, how big, how tall, okay, how flat it is. But what happened? Capacity of this bottle. Capacity of this bottle means how much things it can hold, how much quantity of water it can hold. This this bottle is having the capacity of half liter. Is it half liter? So half liter of water, half liter of quantity. The quantity of half liter can be held by this bottle, by this container. It is called its capacity. How much it can hold, how much it can contain in it is called its capacity. Capacity is the amount of quantity that can hold by the object. Okay, clear. Capacity is the amount of the quantity can hold by the amount of quantity or quantities can hold by the object. Now, how much water is its capacity? How much tall, how much flat, how much big, and they're occupying the space. That space, how much space occupied by this bottle is called volume. Okay, so in that way, what you can see that figure here like this, which is a rectangle or which is a square maybe, okay, anything. So this one flat substance is there. So if you just put again and again on the top, okay, then it will just increase its height like this. Yes or no? Yes. It increase the height like this. Then it starts occupying the space. Now volume comes in, isn't it? Where the volume comes from? Before it is land and the bread, isn't it? Before that it is land and bread, but when it increases again and again, one by one after the other, piling up, then it increases the height. Height is increased, then it becomes the volume. It occupies space and it gains the volume. Before it is flat, then when it increases the height, okay, then it gains its volume. It's having its volume. Okay, clear? And the capacity means how much in that goes can be. It's called capacity. Quantity, how much you can put the bottle inside, how much things you can put inside this solid substance is called its capacity. Now we are going to find out the volume of cuboid and the cylinder. Okay. One thing, 1 meter of length, 1 meter of breadth, 1 meter of height. For example, one object is there, length 1 meter, breadth 1 meter, height 1 meter. So we can find out the capacity, how much the capacity is. Okay, clear? I tell you. See, the volume will be length into breadth into height, isn't it? Yes, there is 1 meter into 1 meter into 1 meter. So there is 1 meter cube. Okay, 1 meter cube. 1 meter cube is the volume of that object. Okay. So how much the capacity? Capacity actually is measured in liters. Capacity. The unit of capacity is liter, that you know, isn't it? So we'll find out then how much the capacity. So the capacity will be in liters. So capacity how much the capacity that we are going to find out. Let us see. Yeah, capacity volume. So 1 meter cube, if we convert into centimeter, okay, if we convert into centimeter, it becomes like this here, 100 into 100 into 100. That means 1 centimeter. So that is this was centimeter. Okay. Yes. That was centimeter cube here. Centimeter. So this per centimeter you are getting here 1,000 liters. Okay, 1,000 liters. So the capacity of the capacity of a container having a dimension of 1 meter length, 1 meter breadth, 1 meter height. That's volume. Okay. The object beside the volume of 1 meter cube here we have the capacity of 2,000 liters. Okay. So capacity is equal to capacity of this object having the length 1 meter, breadth 1 meter, height 1 meter. Okay, we have the capacity of 1,000 liters. Okay, because if we divide by 1,000, we will get here 1,000 liters. Okay, means one. So 1,000 meter cube. Okay, 1,000 meter cube is equal to 1 meter. This you have to remember. The container is having the volume of 1,000. 1,000 not meter is centimeter. Okay, what the container is having 1,000 centimeter cube. The container is having the volume of 1,000 centimeter cube. We have a capacity of 1 liter. Capacity of 1 liter. Okay. So here capacity 1,000 liter because this much of centimeter cube. Isn't it? Divide by 1,000. Okay. Because 1 liter is equal to 1,000 centimeter cube. Then once again 1,000 liters equal to 1 liter. 1 liter is equal to 1,000 centimeter cube. So liter is the capacity. So volume, which is having volume of this much of centimeter cube, that container or that object we have the capacity of 1 liter. We come across this in science also, okay, in class 9. So now let's go to this to find out the volume of some of the solid substance like cuboid and cube. What is the volume of cube? Volume of the cube. Volume of the cube. This L, here will be L, here will be L, here will be L. Isn't it? Yes or no? Yes. So what happens if this increase its height like this cube? So this also will be L. So this is length, breadth, height. Isn't it? So volume of any substances, okay, of volume of a solid substance is length into breadth into height. Okay, that is L into B into height. So here L is L itself, here breadth also L here height also L here. That means L cube. So L cube is to find out the volume of cube. L cube is the volume of cube. Then volume of cuboid. Volume of cuboid. Volume of cuboid is here. Then you to break into height. Okay, here like this. Sort of cuboid. This is length. Okay, this is breadth, and this is height. Okay, on here. Length, breadth, and height. So length into breadth and height is the volume of cuboid, and L cube is the volume of cube cylinder. Regarding about the cylinder, I will just explain you little more. Okay. Now volume of cylinder. Volume of cylinder we have like this. You know this cylinder. Yes. So what happens if you make this cylinder into rectangle? Okay. This curved part will become square, then it will become this rectangle, then L into 2. Okay, isn't it? Yeah. Then yes. So this will be height. Okay, height. Yes. Then this part will become the length. Okay, this part. This is I will making this. Okay. So this semicircle, what will be circular semicircle I am showing here. So what will be circle? So this part will be the breadth, and this will be the height. So what happens? The volume is made into breadth into height. So what happens? What is the length? The length is the circumference. It is twice pi r. Twice pi r. Isn't it? Into breadth r into height. That means twice pi r square h is the volume of cylinder. Yes, my dear student, now to share one more thing that you can just go there is that see this 12 pi r, but what happened you see here before this is understand that this is the half of the circumference, isn't it? That means it's 2 halves. So that means 1 into half into the circumference, isn't it? 2 pi r into r. Okay, into x. So this two will cancel, then it's yes pi r square x. Pi r square x is the formula to find out the volume of cylinder. That is pi r square h is the volume of cylinder. That's all. Okay. See why? Because here you can see this is the semicircle, or this is the semicircle. Okay. So one more review here again. Volume of cylinder is pi r square h. Okay. The volume of cuboid is then into breadth into height. Then volume of cube. Volume of cube is equal to L cube. That's all. Okay. This trick you remember, and we'll go for the next exercise 11.4. So my dear student, now we have this here a cuboid. Okay, the base area. you know cuboid like this, we have like this, okay, cuboid. No, very good. This base area down, okay. This base area is 180 centimeter square, okay. And the volume of this this cuboid is 900 centimeter cube. So we have to find out the height. So in solution, we know that what we know. We know that volume of cuboid is equal to 900 centimeter cube. But implies that what is the volume of cube? Volume of the cube is length into breadth into height. It's equal to 900 centimeter cube. My dear student, please change so carefully. This length into breadth. Length into breadth. This base area will be length into breadth. The base area is given length to breadth. LB is equal to 180. This means 180 centimeter square into inch. Equal to 900 centimeter. Cube. Cube. Okay. So this height we are going to find out. So height h is equal to 900 divided by 180. Yes. That means we are getting centimeter. Okay. That means how much to see this to be cancelled, isn't it? So 18 5 we see. 5. Yeah. 18 5. 5 is 40. 49. Yes. We cut here 5 centimeter. So this 5 centimeter is the height. Therefore the height is 5 centimeter. This will be divided by 5 and 90. So this is the answer for question number 3. Now let's go to next question number. Hello my dear student, now next question we have question number 6. So 4 and 5 you can find, they are very simple, just to follow the formula. Okay, so here question number 6, I will also use question number 6 here. In the question number 6, there one tanker is there who's carrying milk. Okay, tanker milk here. So the tank of the milk, the tank of the vehicle to carry the milk, you can see that it is also a cylindrical tank, isn't it? So the length from here to here is given as 7 meter and radius. So you will find a radius here. Okay, radius here, radius here. So this radius is 1.5 meter. Now it is asking that what is the capacity of this tank? How much milk will carry when they have the length of this 7 meter and 1.5 meter as radius. So what we have to find out, we are going to find out the volume of the cylinder. So if we find out the volume of the cylinder, then we can find out the capacity, isn't it? So first of all, volume of the cylinder. So volume of the cylinder that is pi r square h. Volume of the cylinder is pi r square h. Pi, we know that is 22 by 7 into r square. R is 1.5. 1.5 into 1.5. Isn't it? 1.5 into 1.5, yes, we are getting here, and the height is now the length. Length. If you stand, it will become height. Okay, clear. This will here to here is 7 meter, isn't it? So this will become the height. We will explain it. So this will become the height of the cylinder. So it is 7 meter here. So now we cancel these two, 7 and 7 we can cancel. Then how much we are getting here? We are getting here 49.5 meter cube here. So the whole volume of the cylinder is 49.5 meter cube. So capacity is to convert it to the liter. So what? So we know that capacity. Okay. So you will hear the capacity. the capacity. Okay, the capacity of the tank will be, you know that there is since which is since uh, 1 meter cube is equal to 1000 liter. Okay, see 1000. Why? Because I already told you that 1 meter cube is equal to 1000. No, 1000 meter cube. It is 1000 liter, isn't it? 1000 liter. I told you, isn't it? So here, forgetting about this, so 1 meter cube is equal to 1000 liter. You don't forget this. Okay, clear? So 1000 liter. Okay. But now here what happened? Just follow this. Since 1 meter cube is equal to 1 liter, 1000 liters, 1 meter cube is equal to 1000 liter, then 49.5 we multiply with 1000. That means, yeah, 49500 liters is the capacity. So this is the thing that you should not forget. 1 meter cube. 1 meter cube is equal to how much liters? Okay, clear? You have to. So if you get in centimeter cube, please try to convert it into meter cube. Then 1 meter cube is equal to 1000 liters. Then you can follow. Okay, clear? So this is the answer for question number 6 now. Okay. Let's the next question. We have question number 8. Question number 8 is saying there is one reservoir and its volume is 108 meter cube volume. So we know we have to find out the capacity first. Okay. So we have the capacity first. That means how much the capacity is there in that. But he said that time taken 1 minute per 60 meters to pour the water, to put the water in that volume of reservoir. So how much time will take to fill the reservoir? So there what we have that since volume is equal to 108 meter cube, then capacity will be 108 into 1000 liters. Since 1 meter cube is equal to 1000 liters, isn't it? So there we get here this much of liters. Okay, capacity is 1,08,000 liters. 1,08,000 liters is the capacity. Now in every 60 liters, 1 minute we are taken to fill. So how many hours? Therefore, the total time taken is 1,08,000 divided by 60 into 60 hours. If we want to make hours, it means hours means 60 into 60, isn't it? Then that means we are getting these two cases, isn't it? Then we are getting here 30 hours. 30, we are getting here 30 hours in all together. Okay, at the rate of 60 minutes per, this was 60 minutes, 164 minutes, another 64 hour. 60. That means 30 hours are the time. Okay, so here we come to the questions here. 30 hours to fill this tank of reservoir having the volume